Hello, and thank you for attending today's webinar. So we will begin this presentation in about 1 minute. Hello, and welcome to Successfully Migrate Your Critical Workloads to AWS with Rackspace. My name is Diego, and I'm a Solutions Architect for Amazon Web Services, and I will be your host and moderators for today's presentation. So when you join today's webinar, you select that by join by phone call or computer. So if for any reason you would like to change that, you can do so by accessing your audio pane in the control panel. From the control panel, you also have the opportunity to submit questions to today's presenters by typing your questions into the chat box. And we will collect the questions and address as many as we can during the Q&A session by the end of today's presentation. Also, at the end of today's event, there's a brief survey. So please stay connected until the end of the broadcast and submit your feedback because your opinion is really important for us. And lastly, the PowerPoint presentation will be available through SlideShare, along with the recording of the webinar in YouTube. And we are going to send all that information to you in email in about 2 to 3 days after the conclusion of this event. My name is Diego, and I'm a solutions architect in AWS specialized in migrations. And today I'm going to present a quick introduction about AWS Migration Framework and what is necessary for a successful migration project. And together with me, I have Eric Johnson from Rackspace, and he's going to share a successful migration story from one of our customer OFX, where Rackspace has supported this customer on the cloud journey migration. I'm going to let Eric make the introductions later, but let's begin with the migration framework. So I'd like to start talking about migration framework, especially with this story. So why are customers migrating to the cloud? Why is the main drivers? Why customers really want to go to the cloud? And I've seen a lot of different scenarios when it comes to cloud migration, especially on the motivation side. I would like to share some stories on like customers looking for increasing their business agility. And we have some customers that are creating some business case where they believe their workforce is going to be improved by 30 to 70%, and they're going to be more productive and deliver features much faster as a result of migrating their workloads to the cloud. I've personally seen a lot of data center consolidation projects, especially the companies that have been very active with acquisition and that have experienced infrastructure sprawl over the years. And of course, cost reduction. A lot of companies looking to reduce the cost, their monthly expenditures in infrastructure services, and they see cloud as one really great option to reduce that the cost when their infrastructure operational cost. So while there's a lot of reasons enterprises are motivated to migrate their legacy systems to the cloud, they're asking a lot of questions on how they can do that and how they can do that quickly. At the same time, we have some drivers of why migrating to the cloud. We have some blockers or potential blockers that I would also like to share some details about those blockers and how to solve those blockers. I would like to start with the lack of cloud expertise. So a lot of companies, they have this task to migrate their workloads to the cloud, but they don't actually know how the cloud works or what are the benefits about going to the cloud. And that's where when our partners like Rackspace, they can help you on training or even executing the cloud migration project for you. And that will also help to remove the skeptical stakeholders because As you are migrating your workloads to the cloud and you start getting confident of executing the migration and you're building up your new environment, you see how cloud works, you also help your business to be more confident on accelerating those cloud migration projects. From the technical side, I've seen a lot of application interdependencies because if you're planning your migration, you should group applications together, your application stacks together. And a lot of companies complaining about, not complaining, but a lot of companies concerned about downtime. We do have some tools that can help you on the application interdependency side and also into the how to reduce the downtime during migration. But I'm going to talk more about that later. So most important things that I've seen to have a successful cloud migration is to build up a foundation. And AWS, we have these four pillars in the foundation of a cloud migration practice. And those four pillars are build up a compelling business case, get your people in an organization. I mean, people is one of the really most important pillars when you're executing a cloud migration. And you should use also a migration methodology to execute your migration, as well as define which migration strategy you're going to use to migrate your workloads. And I'm going to cover in details these four pillars. The first one, so when it comes from building up a business case, it's really important for you to analyze the cost. And by cost, I mean there's cost of how much that's going to cost to operate in the cloud, and also how much is going to cost to change this environment or to execute my migration. Whether it's an internal cost or if you have a third party or a professional services supporting your migration cost, your migration efforts, that's going to have some cost. But at the same time, you should also consider in your business case what you're getting out of the migration. And I would say a few factors that are really important, like the increase of the labor productivity, because you're going to reduce the number of maintenance hours that you expend on your infrastructure, as well as you'll get a lot of automation, because if you can automate some of the support and infrastructure tasks, that means you can do more with less. At the same time, after you collect all these numbers, it's really important to estimate a return of investment, because after all, that's the compelling reason for business to make these investments on doing the cloud migration. The second pillar, as I mentioned, is the people and organization. So people, it's the most important factor during the cloud migration, because after all, they're going to be executing the migration. It's really important to create what we call a Cloud Center of Excellence, or CCOE, because CCOE will include all the peoples across the organization which are going to be executing the cloud migration. And these people are also going to define the best practice, governance standards, and discovery automation that are going to drive the change into your company. The CCOE members, they're going to be the SMEs, the subject matter experts in your migration, and also in supporting your environment post-migration. So that's why it's really important to invest time and on creating the CCOE and making sure that the people have the right skills to execute the migration. Once you have the people trained, it's time now to start deploying your migration methodology or your migration process. And this is a very simplified migration version of the AWS migration framework, but it's based on these 5 steps. As I mentioned, you should start with the migration preparation and business planning. That includes the creation of COE and the creation of your business planning. And it's really important for you to define what we call as migration success criteria. And once you have that paperwork and that business case defined, it's time to start the portfolio discovery and planning. So that's when you're going to execute a deep dive into your data center and create a complete map of interdependencies between your applications and define the overall migration strategy of how you're going to execute the migration of your workloads to the cloud. It's also important during the discovery to raise up informations like what's the criticality of your application and how complex your application is. And one piece of advice is you can begin your migration by executing the less critical and less complex application, because it creates a sound learning opportunity for you and for your migration teams. The next step is what we call the migration factory. It's phase 3 and 4 because um, it's a combined process where we start defining the application design per application, and we start migrating and validating each application. And this is a very continuous improvement process, because lessons learned from the application design, you can redeploy those into the migration validation. So it's a very iterating process where lessons learned from one application that you just migrated takes to the next application, and you build up your migration factory using that technique. Once the migration is completed, it's time to hand off to operations. And that's really important that the operations understand how to operate the new business, the new infrastructure, the new model in the cloud. And building off expertise developed from the previous migration of applications enable you to develop a foundation that leads to a continually improving operating model. So that's something that's really important into the deploying a well-defined migration methodology. And finally, once you define the discovery, and it's time for you to define how you're going to migrate your workloads. And we basically have 6 ways to migrate a workload. And I would start the first one, which is the most simple way, is what we call the rehost. So you're basically moving your applications and servers exactly the way they are. It's the same OS, it's the same application platform. You're just lifting, shifting servers from your on-prem environment to the cloud. And you can do that manual by reinstalling the stack, or you can do that using some kind of automation tool like AWS Server Migration Service. The next option is to replatform. So in replatform, you're making a few cloud optimizations in order to achieve some tangible benefits. And I would provide some examples, as I do not want to manage my database anymore, and I would like to use a managed database platform instead, as Amazon RDS or relational database service. So I'm just changing some elements into my application, but it's not really a big change. The next option is to repurchase. That means I'm just buying a brand new application, and my focus now is just to migrate the data. I don't actually have to migrate any servers or any infrastructure or reinstall application stacks. I'm just getting everything new, and I just have to move my data. And the fourth migrate option is to refactor. So refactor, that means I'm redefining and recreating and redeveloping my application to be more cloud friendly. And I'm taking more benefits from the cloud native platforms, for example, using AWS API gateways or Dynamo databases, so and managed services. But actually, it's where most of the cloud benefits are when it comes from elasticity and availability and cost reduction. So, but you have to put some time and effort on rewrite your applications. The last two is not really migrating, but I have to mention those. And you would prefer just to retain the servers, and you only migrate what makes sense for your business to migrate. But there are some portions of your IT portfolio that are not ready to be migrated. A mainframe server, for example. And it's fine, because you can, AWS, we have some tools and features where you can deploy a hybrid cloud, and you can migrate only what makes sense. And the last one is to retire. And that means identify IT assets that are no longer useful, and you just can turn that off. And you're going to be surprised when you finish discovery process that there are a lot of applications that are no longer used that you can actually just start the retirement process. The outcome of this is support is available. So AWS, we have what we call the AWS Partner Network. So we have a lot of partners, and one specialty into our partner network, it's related to migrations, where Rackspace is one of our partners into the migration competency program. So if you need to migrate your workloads, you can check AWS Network Partner. We do have partners specialized in migrations. And we also have AWS Professional Services and migration tools, either for discovery and workload migrations into AWS Marketplace. So they will help you to determine your migration strategy, and they're going to define a very clear roadmap on how you can migrate your workloads. And they're going, actually, they have professional services that can execute the migration for you. With that being said, I'm handing over to Eric.
All right, Diego, thank you so much. So my name is Eric Johnson. I'm the public cloud evangelist and certified cloud architect at Rackspace. I talk about it and I do it. So I get the chance to work with customers like OFX in migration stories onto AWS and where Rackspace can help out. So I want to take some time and tell you about working with OFX and what that looked like. And it really is kind of a reflection of what Diego just kind of talked through on what a migration looks like, because how Rackspace approaches that is much like AWS lays out there. So, all right, let's get started here. There we go. So as we dive into this, first I want to tell you about OFX and what they do and who they are a little bit. First of all, they're global currency experts, right? They've transferred more than 100 billion across 55 currencies and 190 countries. So these guys aren't new at this. They've been doing this, their core competency. They understand, financial transfers. They are headquartered in Sydney, Australia, and they have 2 decades of currency exchange experience. Excuse me. So they came to us with a problem. And I want to kind of talk you through what that looks like, or what the challenge. Mainly 3 core things. One, they were dealing with some rapid infrastructure growth, specifically on their database. Also part of this rapid infrastructure growth is introducing single points of failure. They were dealing with an environment co-location, and we'll kind of get into what that means here in a moment. But the basic idea is their environments were in different places. And because of that, or as a result of that, they had inconsistent environments, which were causing delayed deployments and really this uncertainty. And coming from a developer background, anytime you're uncertain of your deployments, that's a scary thing. Knowing that even though you fix something, I don't want to deploy it because it might break something else. So this was some of the challenges they were dealing with, and there were some fringe challenges that came from that. So let's kind of walk through this and what that means. Excuse me. So in the before picture, one of the critical issues they had was there, again, in this co-location of environments. In their production environment, they had this database that was just this monster huge database. I've kind of overshown it here in the design, but it was one machining running a super large database on it. I mean, they were taping RAM and storage to the side of this box. They needed a lot of horsepower, and they had vertically scaled this database as far as it could go. To offset, to kind of help manage that load, they also had read replicas going on. But the idea here is, again, they had all this data, and their service was being white labeled. What that means is they were other companies were using their payment process under the hood as kind of a white label to handle payments. So they had a lot of companies other than just themselves relying on this data, and they really needed to get it off this single instance or single point of failure. The second part of that is because the co-location, because their data was sitting out in a whole different data center, they had a hard time getting access to their data. They wanted to be able to run some local tests. They wanted to be able to run some things against that data, and the connectivity to the production environment was just broken. They to get it down, they had to go through a lot of red tape, and it became this, it's just not even worth it kind of story. So that's what they were kind of looking at before in the way their data was working. Second of all, in their environment, and this idea of the co-located environment, is what they had as their development environment was not what they had in their production environment. They didn't look the same. So as a developer, a lot of times we'll add, hey, we want this third-party library, or we need this installed, or we need this configuration to happen. But because of the changes or the co-location issues, that was not being run up the stack very well. So what you end up having was this diverging environment. Development did not look like staging. Staging did not look like production. And so it makes it pretty scary, in deploying. It's that, oh my gosh, will this work? So they were desperately looking for a better way to do this. The second thing, or another thing they were dealing with their environment changes, was how their disaster recovery was happening. Their disaster recovery was actually yet in another data center, obviously, because you need somewhere else in case your data center goes down. They need to be able to recover somewhere else. But it didn't look anything like their production environment. In fact, it was fairly under provisioned. So they knew that their disaster recovery probably wasn't going to handle the load that they needed it to handle. So they needed to kind of fix that. So also before picture, there were a couple things that they were dealing with that were causing some performance issues with them. First of all, is they were running as their router or proxy, they were running Nginx on virtual machines. Now, Nginx is a great product, and this is not to say, hey, running Nginx is the bad thing, but for them specifically, they didn't have, there was not a lot of Nginx knowledge in-house. So they were running into configuration issues. And because they were having to their environment had so many different machines, they were having to touch each machine to manage. So what that really means is even if you're doing it right, if you got to do it 50 times, probably one of those times you're going to get it wrong. And so you're introducing human error into your management process, and that's always dangerous. The second thing they were using is Redis for their cache. Again, Redis itself, great product. Redis is employed heavily throughout AWS. In fact, we'll look at that in a little bit. But they were having to manage it themselves, and it was hurting them, really honestly. There were some issues on trying to manage the different machines across all the different boxes, and there's always a chance of getting one wrong. And again, there was some internal knowledge lacking. All right. The final thing they were looking at were some security issues. The way their configuration was set up is every single box, every single computer had a public IP, publicly facing IP. So, and you might be saying, well, what's wrong with that? You have to have a publicly facing IP, for people to reach your internet. And that's true. For people to reach your application, they've got to be able to get to it. But again, what you're looking at is however many boxes, 50, 40, 300, however many, they're having to manage individually. And so the chances of getting every one of those right, especially as you start adding machines, becomes exponentially smaller. And so the management of all those boxes and running a public IP on every box introduced a pretty good security risk. So they really wanted to alleviate that as well. So they knew they had a need. And basically what they figured out is, number one, we need a cloud technology. And two, we need a managed service provider. So they had some requirements. As they were looking at this, they were saying, okay, here's what we think we need. Here's what they came up with. For cloud technology, they said, look, number one, we need scalability. We've already said, look, our database is growing. It grows, incredibly all the time. We need to be able to scale that. We need unfettered access to all environments. We can't go through red tape every time we want to do a deployment, every time we want to grab data, move things around. We need consistent infrastructure across all environments, right? So, and with that, we need the ability to have consistent reproducible deployments. Okay, so we need to be able to say, look, our environments match and our deployments are going to be the same every time across them. We also need the ability to scale to other global regions. One of the things they were doing is everything was there in Australia. They weren't able to scale beyond that, so they needed a provider, a cloud technology that had global presence. And finally, they needed a new disaster recovery plan, and they needed that to be provided with cloud technology. So for the managed service provider, they said, we run MS SQL, so we need a provider with deep knowledge of databases and generally, and specifically Microsoft SQL. We need to understand better how to run Microsoft SQL. We need a provider with deep knowledge of AWS because as their cloud technology, they had chosen AWS for the obvious reasons. We need a provider with credibility in the industry and a provider that worked as a partner. So let me tell you why they chose AWS. Okay, so they chose AWS because number one, they offer managed services. We talked about how they need to offload a lot of their management. So they needed managed services like Amazon RDS, Elastic Load Balancing, Elastic Cache. They needed, again, for this reproducible environments, they felt CloudFormation was the answer. And CloudFormation, if you're not familiar with it, is a way to manage your infrastructure as a template. Infrastructure as code. You may have heard that buzzword going around, but it's this idea of managing all your infrastructure as either a JSON or a YAML template. You may have heard the joke, my other data center is a YAML, which is one of my favorite, but I'm kind of a nerd too. So, and lastly, that global infrastructure. If you look at, and these numbers were good as of April 2018, and we put these dates on because Amazon's always growing. AWS is always growing their global infrastructure. But 18 geographic regions, 4 more geographic regions planned for this year. Some have been established, 54 availability zones. So you get the idea. I'm not going to read all the stats, but you get the idea that AWS has a great global footprint. So the second question is, why Rackspace? So they came to Rackspace as an audited AWS managed service provider because Rackspace has a history of managing production environments for thousands of companies worldwide. Many of the Fortune 100 companies come to Rackspace for our expertise. We have a thing called fanatical service, and we are absolutely fanatics about going above and beyond every time we talk to you. Rackspace, we guided OFX in migrating their application portfolio to AWS. We had the skill set on AWS, and our expertise in application database management helped move OFX beyond migration, take full advantage of flexibility and resiliency of the cloud. And I want to talk this, we say managed service provider because that's kind of the label that's put on these, but really I want to talk to you a little bit about the difference between a provider and a partner. And Rackspace really looks at itself as a partner. And a provider, they tend to, do the work for you, first person in the queue, first person helped, whereas a partner helps you with the work or walks alongside of you, and they're constantly with you, through the whole story. And so we really walked side by side with OFX, and you'll hear more how we did that as I start to list out, the way we did that. So when we talk about the process, again, it's a journey together. We work with OFX, we work with AWS to build this really amazing architecture for OFX. And here's how we do that. Much like Diego laid out, we walk through these steps of planning, analyzing, designing, migrating, managing, and optimizing. And what that looks like basically is we will come in and we will bring a team in to help you create that CCOE that Diego was referring to. Where we will come in and help you decide, okay, who are the right people? What is the right approach to building our CCOE? So this is even before we look at a workload. This is how do we get you cloud knowledgeable? Right? How can we help you build this infrastructure that's going to be able to support this architecture that we're building, and then the continual transformation and optimization and all the things that go there. So the next thing we do is once we've kind of established that team, we've established this process, we sit down and we analyze your workload. And we look at it, and we don't always say, all right, how do we do what you're trying to do on AWS? Because that doesn't really help you out. What we do is we look at what are you trying to do here? What is your workload doing? And how is that best done on AWS? And a lot of times that may be a difference between a re-architecture and a re-platform, right? Or a redesign or a rebuild or all the R's that are listed there. So once we've kind of analyzed that, we've taken it back to our solutions architects, such as myself, and we sit down and we go, okay, we're going to produce a design that we feel works best for you. And we're going to walk through that design and build, okay, this is the architecture. These are the best practices. We're going to look at things like scalability, durability, security, all the other abilities that, that are available so that we hit your best practices and we build a well-architected framework for you. Once that's done, a lot of times that's okay, here you go, good luck. But as a partner, we come and we actually do the migration for you, or better yet, with you. And so part of the planning is, all right, how do we do the migration? How do we test it? How do we make sure it works? How do we validate it in your eyes to make sure that it's a good migration? And then we actually do that migration. Okay, so once we get you over, we get you in production, the migration's done. And that's not when we walk away. After that, you get Rackspace's skill and expertise for 24/7 monitoring. We're the guys that either get the call in the middle of the night if we need to, eyes on screen, automation, tracking, different things like that to manage your workloads. And then we also start recommending optimizations to you. So because a lot of times, realistically, you can't get everything. You can't move a perfect workload into AWS. Sometimes you work with people that come to you. If you'll do these 30 things before you move to AWS, it'll work great. But that's not realistic. So what Rackspace does is more of a realistic approach. Says, look, these 3 or 4 things have to be done before we can move you. But then we're going to move you. So it's kind of this hybrid lift and shift, a little bit of changing, a little bit of refactoring. And then after that, then we're going to start saying, okay, now how do we optimize and how do we transform your workload to really let you take advantage of cloud native technology? Because that's where you really save money, and that's where you really find agility, and that's where you really find power, is if you're cloud native as much as possible. So that's how we run our migration platform. So applying that to to OFX, really a lot of the planning and analysis came down to the application discovery and the database discovery. We actually had one of our solution architects, our DBs, DB admins, go in and sit in the OFX offices for quite a while. It did a lot of work on helping them understand what their database is going to look like, what the architecture was going to look like, how we can move them to some managed services, things like that. And so in that realistic migration plan that I was talking about, number one, we said you've got to go infrastructure as code. If you want the flexibility and the matching, infrastructure like we talked about, you've got to do that. We've got some architectural improvements for you. We've got a data migration plan. We've got test plans, and here's the time frame, right? So what we did then is we actually stepped in and started doing it. So the steps for them were pretty straightforward when you look at this. First of all, we created a non-production environment on AWS. We said, all right, here it is. Here's the sandbox. Start playing around with it. Does this do what you expect it to do? The second thing is in the analysis and migration of Microsoft SQL Enterprise, we decided to move them to standard. They were using very few things that they needed for enterprise. They really didn't need enterprise service, to be honest. They were able to run SQL Standard just fine. And what does that mean? That means they saved a lot of money in licensing, right? So they were able to run Microsoft SQL Standard on Amazon RDS. Okay, so we set that up for them, and finally, we created a production environment on AWS based on all the testing and user input, things like that. When all was said and done, we point the DNS, all the test pass, we repoint the DNS, and voila, they've got an architecture running on AWS that is running managed services. So let's take a look and see what that looked like, and I can kind of talk through this and why we made some of the decisions we did. So first of all, you remember the problem they had with Nginx? Again, Nginx itself is not a problem, but they were having to manage all the Nginx instances. They were having to manage, and they were having issues and losing traffic because they didn't understand how to configure in Nginx to its full optimization. Instead of running Nginx, we moved them to the application load balancer, where they were able to handle path-based routing, different things like that. And so this is one point of management. So rather than having to manage a bunch of different boxes, they only manage the application load balancer. And the reality is we managed it for them. We have experts that are able to set that up in the architecture. And you might be thinking, well, that's a single point of failure, but that's the beauty of AWS. And although that looks like one icon, behind the application load balancer is a pool of warm load balancers that are constantly rotating in and out. It's not a single point of failure. So what we've given them is a single managed point, but not a single point of failure. The second thing we did is we still kept them on Redis because we think Redis is a great caching engine, but instead of managing that themselves and running it on EC2 instances, we moved them to Elasticache, which is a managed cache service that AWS offers, and we ran Redis. So they were able to run, it's replicated into 2 zones. So you see availability zone 1, availability zone apparently 1 as well. And so we were able to replicate it in 2 zones. And so they don't have a single point of failure, but that cache is always there and it replicates between each other. The third thing we did, as I talked about earlier, is we moved them from SQL running on a single box with a bunch of read replicas, and we moved them to a SQL on RDS. Okay, so with RDS, what that gives them is the ability to scale their hard drive as needed. You could do some vertical scaling, but you can also do some horizontal scaling and read replicas and such. You also have failover through what is called the multi-AZ setup. So if their master server were to go down, their secondary server would kick in. and there would be failover, and AWS handles the rerouting. So a lot more durability in their data. It's being backed up, and they can still do read replicas and such. So, and the ability to scale. Hey, we need a bigger instance. So they're able to say, okay, this instance isn't carrying it, or the amount of database or storage isn't carrying it. So we can upgrade both of those with very little interruption or downtime. And finally, with instances, the standard auto scaling, where we can grow and shrink. The beauty of auto scaling is we can grow as load determines, but we can also shrink as load determines. So rather than over provisioning, you're meeting or slightly exceeding your load so that your application is always responsive. So that answers a lot of the security issues. Also, the application load balancer is the single point of entry. So we don't have a public IP anymore on all the machines. Just the application load balancer has a public IP, and that blocks anything from coming in. You'll notice we also have everything in private, the private subnets. So you have to go through the application load balancer, and it has to be on the right port. So that answers the security and some of the infrastructure issues they were dealing with. But when we're talking about multi-environments and how do we manage them, we're able to manage that as well. And you see on here, we have a non-production environment that looks much the same. So we're able to save them some money. There's no sense spinning up a bunch of instances that we don't need, but we do want like instances or like infrastructure for testing, because obviously we want to test on the same thing. So we have a Redis, we have the instance, we have a load balancer, we have SQL on RDS, everything needed, but only in one availability zone. So they might even be smaller boxes. It kind of depends on what you're doing. But we're able to do this through the magic of CloudFormation. So with CloudFormation, what we're able to do is say, okay, this is my template, okay, and I'm going to parameterize my template. I'm going to tell it, hey, one of the parameters I'm going to pass is an environment parameter. So if it's development or staging, only build one availability zone and only build infrastructure in that availability zone. If it's production, then build it out in 2, 3, 4, 5, or however many availability zones, so that so obviously we have high availability. And by doing that, I can parameterize my CloudFormation and build that out. Now here's where this gets really cool, is I can use that CloudFormation in multiple regions. So I may build up a region in Australia, or I may build something out, or I may build up a region in the US or in Europe. And all I have to do, instances are tied to the region, so I have to change the instances I might be using. But again, those are parameters. So I can say if US, use this instance. If ANZ use this instance. So they have this ability to maintain their full infrastructure in a template. And you can version that, right? You can store that in code commit or GitHub. And then as you make changes, you can even run a continuous integration, continuous delivery against your architecture that updates that architecture as needed. So you have a lot of power there. The one other thing I would point out is here on the right side where it says SQL data and you've got the arrow pointing out, we're dropping snapshots for them. We could do manual snapshots into a bucket, outside of the normal snapshots that might be happening just to back up the data. But we could say, look, every night we're going to drop a snapshot of the data to a bucket, and you have full access to that. You no longer have to worry about the red tape of a third-party co-location. You have full access to that based on IAM security, so we're not opening it up to everybody, but based on who you are logging in as, you have access to grab that data and do what you need. So it's a lot of flexibility that we've answered the questions of security, infrastructure, like infrastructures, the ability to reproduce that infrastructure over and over and over. So let's look at the takeaway. When we go back to OFX, we say, hey, what was the takeaway here? What was the best thing about this? I mean, we've done a lot of work and we're still working with you and we're your partner, but what would you consider the takeaways? And here's what they told us. Is that first of all, confidence. Again, going back to I've been a developer forever, and going back to being that guy that's developing and knowing that he's pushing code, and of course, I always worked for a company that wanted to push code at 4 o'clock on a Friday afternoon. So that ensured that I'm going to be on the phone or up late night Friday and Saturday night working, right? So what they said is, by giving us this ability to build the multiple environments and have scalability and replication through data, through our RDS, have elastic load balancing that's managed, elastic cache that's managed, and through the auto scaling that handles load, and through CloudFormation, you've given us confidence that our environments are going to look alike regardless. Right? So if we hold to the policy of maintaining our environments through CloudFormation, we know they're going to look alike. We can create a beta, create a stage, we can create a production, or we can even create some edge location that we want to test some new stuff. Right? So that gives us the confidence to work with that. And when we asked them, we said, look, the confidence that a managed service provider gives us, obviously you did all this work on AWS and the confidence that AWS technologies give them, but the managed service provider says, look, we have a service provider that works as a partner. We can submit tickets, and those tickets don't have to be, hey, service A is broken. They can also be, hey, we're not sure how to do this. Can you help us? We need to add this. Can you help us? By that, they're tapping into the deep expertise that we have. We have over 1,000 certifications in AWS alone. And the people you work with are guaranteed to be certified. When you talk to me, I'm certified, AWS certifications. And so the expertise and the way we do it is kind of interesting. Like, my expertise would be probably serverless or development, plus the overarching architecture. But we have other guys who are database monsters. I can barely spell database. These guys are database monsters. We have other guys that are security experts. So we work these together to provide this really rounded out expertise. And finally, you have 24/7 presence, right? So Rackspace is not, hey, we're there 8 to 5, and then then we're not available. You'll get a voice every time you call Rackspace, 24/7. We also have people who work in our data centers who are watching services, watching for threats, different things like that, 24/7. So that gave them a lot of confidence. The next thing they said is increase productivity. Bottom line is, if we can offload infrastructure management, it frees up time for us to do what we do best. We're not infrastructure guys, we're payment processing guys. So we are able to go to market much faster with changes in service increases and in improvements on the platform and new features and different things like that, because we don't have to manage. We know that we develop, we push, we test, it goes into production. And we can do that multiple times a day because we're not dealing with third-party co-location. We're not dealing with inconsistent infrastructure. We're able to trust our infrastructure and trust our provider. And that's really the end of the story of OFX. And at this point, I'm going to turn it back over to Diego, and we're glad to answer questions as needed.
All right. Thanks a lot, Eric, for sharing some of the story around OFX migration. I really appreciate it.
Absolutely.
Okay, so let me check for a few questions in the pool. Okay, so from the architectural standpoint, what would be the next step? I mean, what would be the evolving portion of this existing infrastructure or this implementation that you just migrated?
That's a good question. So like we talked about with this idea of when we migrate someone, a lot of times it's a realistic migration, right? We move them over kind of with what they've got and some basic optimizations. And then we do continual optimization. You get them as much as we can get into these kind of native cloud services. And I think for OFX, the things I might look at, number one is we'd probably look at either containers or serverless to get them to where even more they hand off architectural and they're able to handle things at an event-driven, especially with serverless at an event-driven level. And so that would be one thing that I would suggest them. Also, the thing they deal with as I pointed out, and we were able to deal with RDS, is this massive scale of data. Their data just grows. Every day it's growing incredibly. And now this would be a bit of work. I'm not going to lie, but I would almost look at migrating to either MySQL or Postgres so that they can take advantage of Aurora, and specifically Aurora serverless. Because Aurora is going to scale storage as needed instead of you having to upgrade. And RDS makes upgrade easy, but Aurora completely removes that. And I know that's a big change. Oh, hey, you're changing databases. But with services like database migration service or the schema conversion tool, that's not as crazy hard as it seems. So if I wanted to go from MS SQL to MySQL, I could use the database conversion schema tool, or database schema conversion tool. There it is. It's early where I'm at, so talking is hard. And I could start looking at moving that over to Aurora and take advantage of Aurora and Aurora serverless. So I think those would be some of the next steps that we'll be talking with OFX about.
All right. So we had the situation that you described before about the disaster recovery side. So does the lack of an actual disaster recovery side make the customer nervous?
Also a good question. I didn't point out in there. Yeah, you're right. There wasn't a disaster recovery site. So what they decided, and really, if you look at it, is a multi-AZ implementation was their disaster recovery, right? So one of the things they've done is by running RDS, by running the instances and separating their infrastructure from their code and having the ability to bring up new infrastructure as needed, they felt, okay, one, we have snapshots, we're not going to lose our data. Even if an entire AZ or region went down, we could come up with another region, especially because going down, and we haven't done it yet, but moving forward, they're looking at coming up in another region. And so by the multi-AZ and the multi-region implementation, they felt we don't need another DR, or that was the DR. If you think about it, it's almost an active DR by having a secondary region.
All right. There's another question. Can you talk through some of the architectural choices you made for the final environment?
Say again, I'm sorry?
Can you talk through some of the architectural choices you made for the final environment?
Yeah, absolutely. So again, talking through, it was interesting when we sat down and had the MS SQL conversation, and looking at, they were running enterprise, and a lot of times, okay, running enterprise, so we'll run an enterprise on AWS. That just makes sense. But we started to evaluate. You look at, why are you using enterprise, and that's a question that I think anybody should ask themselves. If I have choices in licensing, why am I choosing the most expensive? Now, sometimes it may be, here's why, and that makes sense, and it's worth the money, and you move on. But sometimes it'll be, it's just always what we've been doing. It's what we've done. And so in this case, I think that's a little bit of what it was. And so by evaluating that and saying, okay, really honestly, and man, I'm not dogging Microsoft SQL at all. It's a great product, but it doesn't make sense to pay for a license for features that you don't need, right? So by dropping them to standard, that saves them pretty good chunk of change that they can apply elsewhere. And so that was again, that's the architectural question. I think it's always good to ask, why are we doing it this way? Is it because it makes sense and it's the best way? Or is it because that's just what we've always done? Kind of the same with the Nginx and the cache. The caching on Redis was a great idea. I mean, cache is always a good idea. Anytime you can take the load off your database, you can take the load off your servers and say, look, this is in memory, it's ready to go. That's good. But managing, each individual instance and each individual pop, it doesn't make sense. If I can move that into a single managed service, then most likely I'm saving money rather than running a bunch of instances. I haven't done the math on that, but it's going to be comparable or less to run a managed service. But two, I'm saving a ton of time, just man hours, right? people hours. So the architectural decision there, thought process is, you know, people hours versus, the price of instances, but, or running a managed service, but good chance that's going to be cheaper anyways. So those are some of the things that we come in and when we talk through, those are some of the questions we ask.
All right. I have another question. So, what was the biggest challenge of this migration?
Oh, the database by far. Yeah, the database by far, because it literally was the monster in the closet. I mean, it was there. It was there. I mean, everything depended on that. You have, however, 300 white labeled companies running on this same database. And we knew that, one, we had to get that so it wasn't a single point of failure. We had to move that. And that's, it's an easy answer with RDS, but the thing is, how do you get there? And so, I talk about moving from enterprise to standard. There was a little work we had to do. And that's our DB services actually came in and sat in their offices and worked with them on that. Here's some of the things that need to happen. Here's some of the changes that need to work through. And then the migration process of moving one from SQL Enterprise to standard, and then two over to RDS, migrating that data over, was probably the toughest one. So yeah, I would say that's probably it.
All right, and I think we have one more question. So, is having public IP addresses on your application service really a security risk? What if you have properly locked down them using a firewall?
Yeah, and there's different schools of thought on that, but I would say, best practices for us, at Rackspace, if you remember the architecture, is we put everything in a private subnet. Okay, so and this is probably going to be more lengthy than probably it should be, but when you think about security, the reality of security is not if but when you're hacked, right? That's just the reality. Werner Vogels is famous for saying everything breaks. And that's probably a paraphrase, but Werner Vogels, the CTO of AWS, said everything breaks. The reality is we're not building something that's never going to break, but we're building something that can recover from breaking or recover from being hacked. And you want to do the same in your infrastructure. So when you think about security in AWS, you think about layers. Okay, so there's, the account is your first layer. Who can get into my account? Then you look at the VPC. Then you've got availability zones. Then you've got subnets. Then you've got security groups. Then you've got NACLs if you want them. And then, and so you have these layers of security. And again, one of the best practices is we drop everything into a private a private subnet. And that private subnet has no internet access. But if you wanted to have a public IP on each one of those, that wouldn't work. So by moving those into the public zone and giving each computer a public IP, you're removing an entire layer of security that's available to you. Okay, so that's the first problem with that. The second problem with that is the one that I talked about in there is you're also having to manage those at each individual point instead of one central location. And so by redundancy of, change this, now go to this one, and you might use something like Chef or Puppet or SSM or something like that, and that's good. But again, you're still going out and having to touch each box. There's always room for failure. Whereas when you're managing one central point, which would be in this case the load balancer, there's some tests that are wrapped in place. AWS has some guardrails up to help you with that. And two, it's a single point. And that doesn't mean you won't do that wrong. You get in there, go, oh, that's wrong. But that does mean that it's easy to remediate, right? Oh, we got that wrong. Let's go back in and fix that. Well, let's fix it one place. Boom, it's done. Takes longer to say it than to fix it sometimes. So yeah, yes, even, and you may have your, look, we run internal firewalls on the computer. They are locked down. We got whitelist or blacklist or whatever, but you're still having to, the management and the removal of the security layer to me is not worth really, and I don't see any advantage in it either. Because we can provide public IPs through a load balancer for DNS, especially with the network load balancer. There's not really a purpose for it. Every once in a while, we'll find a story that we kind of need to do that, but it's a real edge case.
All right. Yeah. So those are all the questions that I had. So thank you again, Eric, for presenting this success migration story. I really appreciate it. And thank you all for attending today's webinar. Please remember to stay connected and complete the survey as we finish this webinar. And we look forward to support you in your current and future projects. So thank you again and have a nice day.